Hey guys, welcome to this video in which we are going to focus on automated machine learning with Microsoft Azure Cloud. I'm sure you guys have understood the connection between AI and ML so far because we have gone through our Azure AI fundamental videos. Now, obviously AI and ML both are connected, but then in this particular video, we are first going to focus on how exactly machine learning model works, how exactly we can use our data and train the machine learning models. Obviously, there are multiple ways to do this thing. We are going to use Azure ML, which is a Microsoft Azure Machine Learning service. Now, we're going to use that service. We are going to train the model from scratch based on some data. And then I'm going to show you that how exactly we can deploy that as an API so that we can consume that model and we can develop our applications like AI. So let's get started with this. The first thing is I have already logged into my Azure portal right now, and I'm going to create a new resource. Because we are going to do all the things step by step, I want you to make sure that you understand things properly. And if you also have Azure subscription with you, I strongly recommend you should also try this labs to understand it betterly. Let's move forward with machine learning. So I'm going to search for machine learning, and I'm going to get machine learning workspace with that. We are going to create a new machine learning workspace, which is a service allowing me to do all the machine learning model training with that. We'll click on create machine learning. I already have my own Azure subscription, so I have selected that subscription here. In the resource group, we are going to create a new resource group called AI-900 RG because this videos will be a part of the AI-900 course. The name of my machine learning workspace, I'm giving something like my name, MLWS25, because this is 2025 now. If you are not learning machine learning and AI in this year, then when exactly you're planning to do that? Well, this is a perfect time to do that. So I'm glad if you're learning this. And we're choosing a region which is going to be East US. This service is actually going to create a couple of other services with that in which machine learning is dependent. So you can see right now we have a storage account, we have a key vault, we have application inside. These three services are actually going to be created in the same resource group in one deployment. So when you provision this machine learning workspace, which I'm going to do right now by clicking on this review plus create, this is actually going to create all this dependency resources as well as machine learning workspace also with that. Now, obviously, this is one of the easiest way to create a machine learning workspace using Azure portal. As per your knowledge, I think you know that we can also do this thing by using PowerShell scripting or using the internal Cloud Shell prompt with the batch scripting. So all these options are available in this Azure Cloud. We'll wait for this deployment to be completed because it's going to create my machine learning workspace, and inside that workspace we are going to have something which is Machine Learning Studio. That Machine Learning Studio is going to provide that environment where you can actually train your model, you can configure multiple experiments, you can execute jobs. There are multiple things which we are going to see inside that. By the way, while we are waiting for this deployment, I want to remind you one thing, that if you are not familiar with machine learning fundamentals, I strongly recommend you to go through this particular video, which is visible on the screen in that I symbol. This is our previous video, which is going to show you machine learning fundamentals. And I strongly recommend you understand the fundamental, how exactly machine learning works. And then after this, if you do this lab, that's going to make this concept crystal clear. Yes, our deployment is completed. Let me click on go to resource. And most of the time, we do not have much things to do in this Azure Machine Learning workspace inside Azure portal. Instead of that, we will click on Launch Studio. So Launch Studio is actually going to give me a separate space, which is a separate portal kind of an environment, which is available on ml.azure.com. This is a place where you are going to do A to Z of everything of machine learning in Azure Cloud. You can also associate multiple Azure machine learning workspaces here. Now, right now, this is my workspace name. And as you can see, this is showing me that I can create generative AI with prompt flow. We can do associations with generative AI models, which are ready-made AI models available from OpenAI. So we have GPT-4 models, we have Microsoft models like Aurora, And if I go next and next, we have so many models from different companies. Even Llama models from Meta is also available in this. We're not going to talk about generative AI models in this particular video, but if you are interested in learning any of these models, please comment down in this particular video. I will make sure that you will get a video dedicatedly on any of the models which you choose. Right now, what I want you to focus is on this area where we have a section for authoring machine learning models, and we have automated machine learning, we have designer specific machine learning, we have notebook specific machine learning which we can configure. In this video, we are going to focus on automated machine learning because I'm assuming that you are focusing on learning AI. Machine learning is something which you do not need to go in depth, but you need to understand what exactly machine learning is and how exactly all these models are created. And that's exactly what we are going to do right now in this particular one. So I'm going to go into this automated ML, and what we are going to do next is we are going to create a new automated ML job. Now, before I create this automated ML job, I just want you to understand one more thing. So I'm going back to my Azure portal. I'm going into my AI-900 RG resource group, and I hope you remember that there are a couple of other things which got created with our machine learning workspace. One of them thing was this storage account. Right now, this storage account is connected with my machine learning workspace. And if I go into the containers section, which is actually going to show me a blob containers of this particular thing, it's showing me that Azure ML blob store. This is actually a blob store which got configured automatically with your machine learning workspace. Now, why I'm showing you this thing right now? As of now, if I go into this blob store, it does not have any data. It's showing me no results here. We are going to do some configuration with automated ML, and we are going to associate some data with our automated ML process. Now, in this case, the data which we are going to use is coming from this particular link. Now, this is a website which is capitalbikeshare.com, which is having a system data available here. Now, this is the data which I have already downloaded in my computer, and I'm going to use this thing. If you want to use the same data for your machine learning model training, you can use it. Otherwise, if you have any data which is in JSON or CSV format, you can actually add that data and then you can train your models on that. Now, this is a very official data kind of a data files which are available here, and we have a license agreement also which is available for that. So you should not use this thing unauthenticately actually. So this is how we are going to do this. This is a data which is available on this URL, but let me just go back to my automated ML and let me show you how we can actually configure this automated ML process. Now, in this case, I'm going to create a new automated ML job. When you create a new automated ML job, it's going to give some random dummy name for this particular job. So you can see right now my job name is having some name like mango brick with some unique name which is associated with that. Now, you will also get this kind of a name. It's not very important. This is a job name. But yes, in this job, when I'm going to create an experiment, I want to give a proper name for this experiment. So I'm going to give a name that this is my experiment name, which is having a name MS Learn Bike Rental. Now, for your kind of information, this is an official lab which is available on Microsoft Learn website. The link of this lab is going to be available in the description of this particular video. So you can just check out that if you want to see each and every step which we are doing right now. The description of this particular one, I'm going to specify like this: automated machine learning for bike rental prediction. And then we are all good to set up our automated ML job. When we click on next, the first thing it is asking me is what kind of a task type you want to choose. Now, obviously, depends upon the algorithm which I want to apply and depends upon the outcome which I want to predict, we have to choose our task type. In my case, I'm going to choose regression because this regression is going to help me to predict continuous numeric values. I hope you understood this from the fundamentals of machine learning video. If not, you can mention any of this particular machine learning algorithm type. So you can comment down that in this particular video, and we are going to create a new video on a specific machine learning type in which you're interested. After the task type, we have to select our data. And as we are going to use this data from a capital bike share, which is giving me a bike rental data, I'm going to click on creating a new data set. Name of the data set, I'm specifying something like bike rentals. Description of this, we are going to say that this is going to provide a historic bike rental data. And in the type, I'm going to choose table, which is going to be ML table. Remember, this is a one particular data asset type which we are going to use whenever we are using Azure Machine Learning version 2 API. This is a newer API which is launched recently, before few months only, and the older one was actually taking tabular data. Now, as of now, you can use both of them, but because these videos are focusing on more advanced machine learning in future, I'm going to always choose table which is having ML table option with the version 2 API in all my videos. So I'm choosing this, I'm selecting next. In the data source, we have to choose a source for your data set. Now we are going to choose it from local files. So we are going to actually upload it here, and that is what we are going to choose. Next, it's going to ask me that, okay, once you upload the files, it's actually going to be uploaded into your blob storage, and that is your workspace blob store. Remember, this is the blob store which I have shown you in the separate tab. So this is actually not having any files right now, but once we try to upload the files, it's going to be available inside this blob store. Let's click on upload folder. I have this bike data available in one of my downloaded location. I'm going to upload, and this data is actually available here. It's having one CSV file and one ML table. Both of them are uploaded using that particular folder. I'm going to click on next, and I think it's all good. The review page is showing me that this kind of a data asset you're going to create. I'm happy with this. I'm going to click on create. Once this data asset is successfully created, you will be able to see this thing in your Azure Blob Storage. Because it's connected with this machine learning workspace, we will choose our task type, we will choose our data set, and then we are going to click next, and we're going to configure this. But before I click on next, let's just cross check the upload happened successfully or not. If I refresh this page now, we have a folder called UI. Inside that we have today's date, and then inside that we have bike data, which means yes, it's successfully uploaded, and we have the data files also. Everything looks good. Let's move to next step. In the task settings, there are a couple of things which we have to configure. The first thing is you can choose what kind of a targeted column you are going to use for predicting this particular model outcome. Now there are so many columns which are coming from the data which we have uploaded. We are going to choose a column which is rentals, because this is that column which I want to use for predicting the rentals of that particular month or that particular duration. So I'm choosing renter, which is an integer column, and for your kind of information, regression algorithms are perfect for predicting a continuous numeric value. This column is integer, which means it's going to have numeric values in that, which makes sense. In the view additional configuration settings, which primary metric I want to focus. So when I'm going to focus on the performance of this model, what will be my primary metric is something which is very important. I am choosing normalize root mean square error. That's what I want to go for. No, I do not want to explain the best model. If I do this thing, it's going to take little extra time. Normally in my real machine learning model training, I always explain the best model so that we can understand better. But as of now, I don't want that. And no, I do not want to use all supported models, because in that case, it's again going to increase the duration of the machine learning model training. In my case, from the allowed models, I'm going to choose some of them. Let's say right now, from the list of the models, I am going to choose random forest and light GBM. Now, maybe some of you are not familiar with what are these models, what is the meaning of SGD, or what is the meaning of gradient boosting. If you want a special dedicated video on any of these models which are there in the list, please comment down that model name in this particular video, and I will make sure that you will get a dedicated video on that very soon. As of now, I'm choosing random forest and light GBM, so I'm not going with multiple models because I want to save my time of model training right now, and I'm going to click on save. So additional configuration is done. These two models are selected. Then we also have a setting for view featureization setting. Now I'm not going in depth into featureization right now in this video, but you can actually customize based on your columns and other featureization configuration. There is a section which is very important in automated machine learning, which is limits. Basically, this is going to help you to control when exactly you want to end the model training. So how many maximum trials you want to run, how many maximum concurrent trials you want to run, how many maximum nodes you want to use in this, and then what will be your experiment timeout. These are all important values. I'm going to provide that I want 3 trials, 3 concurrent trials. Max node is also going to be 3. My metrics code threshold, which I'm going to use, is going to be 0.085, and that is perfect for me. Experiment timeout, I'm going to specify 15 minutes in both. And do I enable early termination? Yes, I want that. So if this is going to take a little long, I want that I can enable early termination from my side, so I can terminate this, and that's how we are going to configure. In the validation type, I do not want automatic. I always prefer to train validation split. So I'm going to do a train validation split with 10% of validation of data with that. So it's going to be divided based on number of percentage which you're going to choose in that. I'm okay with this. I'm going to click on next. Every time when you want to run automated ML job, you need a compute. And this compute can be either CPU or GPU, depends upon the data, the amount of data which you have, the number of models which you're selecting with that. Obviously it's going to require higher GPU or higher CPUs and more time. I'm going to go with serverless right now, which is one of the cheapest option available in this. So I'm going with serverless CPU. I want a dedicated virtual machine with this kind of a size, and the number of instances which I want is 1. So I'm not changing anything in this. I'm okay with all this, and I'm just going to confirm everything is correct in my reviews tab. Looks fine. I'm going to click on submit training job. Now, once you submit the training job, this is actually going to use your data, and then based on that, it's going to train your model based on those algorithms which you have selected. You can see it's showing me right now the status of this job is not started. If I wait for some time, very soon it's going to show me that the job is successfully submitted, the experiment is going to be executed, and then it's going to be coming into the running state. You have to wait for a few minutes. If this is going to complete this particular thing in 15 minutes, it's going to show you the best performing model from that. We are going to see that part. So just wait for some time. You can see right now it's showing me running. They are setting up the runs. They are going to spin up that virtual machine which I have requested with that kind of a serverless environment. In that virtual machine, they will try to execute those algorithms with machine learning. This is a complex, lengthy process. But because you are using automated ML, you don't need to worry about the internal configuration of that. If you want to take control of all the things in your hand, and if you want to apply your own conditional logic in that, we will see the designer kind of a machine learning configuration very soon in the coming videos with machine learning. But as of now, let's just wait. We will wait till the status of this is showing me successfully completed, or until I'm getting some models here in this particular run summary. So just fast forward to this particular video. I'm going to do that thing, and then once it is done, we'll continue from this point. Okay, now in my case, you can see that it's showing me that the status is running, and it is actually doing model training right now. This is the time where we have that 15 minutes timer which is going to be started, and then after 15 minutes the job will be terminated. Now this also reminds me one thing, that if you have reached to this point and if your model is also under training, so this is the time I want to mention that if you are liking this video so far, this is the perfect time that you can click on the subscribe button of this particular YouTube channel, and you should not forget to click on that bell icon so that whenever we publish a new video, you'll get a notification of that. And also, if you're liking this video, it's really useful if you just like this video by pressing the like button. Thank you. Let's wait for this model training to complete, and then we'll move forward to see the result of this particular model training. Okay, now as you can see right now, it's showing me that the status of this particular job is completed. And because the job is completed, it means that we got some models which are actually prepared with the help of this particular machine learning model training. At the right side of this section, I am showing you that this is an algorithm name section in which they are showing me voting and symbol. Now I'm going to click on this algorithm name so that I can get inside this. It's showing me the model summary. The algorithm name is voting ensemble. This is maybe the normalized root mean square error value for this, which is 0.087, which is coming. The sampling is 100%. And this means that this particular model is successfully created based on this. Now, if I want to deploy this model, or if I want to test this model, I can do that thing. But before that, it is always advisable that we go to the metrics tab. In the metrics tab, it's going to show me a couple of metrics which are actually used when we are training this model. I want you to focus on these two values here. We have two graphs below this. We have residual and we have predicted true. Residual chart is going to show you the difference between predicted and actual value in a histogram chart, and that's what which is actually visible here. While the predicted true chart is going to compare the predicted value with the true values which are visible in this. Now, obviously, based on this metrics, you will be able to understand that whether this model is one of the best performing model or not. As of now, obviously, this is not a very best performing model because we have run this thing for a very limited time. Now, if you want to deep dive into the other models which are generated with this, like I can go back to my job name, which was Mango Brick. Yes, I can click on the models plus child job section, and this is going to show you that this is the one model which we have just now checked. You have some other models also which are actually generated with the help of the same process, and you can click on this. You can check the same kind of details with those models. As of now, I'm going into my same voting ensemble model, and then if I want to use this model, then I have to deploy the model and I have to test the model. I'm going to click on this deploy section, and there are multiple options in this also. You can do real-time endpoint deployment, you can do batch endpoint deployment, and you can do web service deployment. In our case, we are going to choose real-time endpoint deployment. So this is going to give me a real-time endpoint which is going to be live and available to test. It's giving me a configuration for this. I'm choosing that instance count for this will be 3. Standard DS3v2 is perfect for me, which is going to give me 4 cores and 14 GB RAM. Remember, this depends on your subscription quota. If you are not able to deploy this with 3 instances, you can reduce the instance counts to lesser number, and then it's going to allow you to do that thing in your subscription. The endpoint name is going to be a new endpoint with this kind of a name, which is also randomly generated. I'm okay with that. Deployment name is also fine. Everything else is fine. I'm just going to click on deploy. Now, obviously, if you do not have enough quota, I'm again repeating, decrease the instance count from 3 to 2 or 1. Or sometime it is also possible that this specific virtual machine SKU is not available. In that case, you have to go for the other options which are available in your subscription. So this is something which is a workaround. You have to figure out what kind of quota which is available in your subscription. It's showing me that model deployment is successfully triggered, and obviously it's going to take some time. Normally a model deployment can also take 5 to 10 minutes. So this is the time. We will wait for some time, and then once the model deployment is completed, I am going to show you how the endpoint looks like, what kind of configurations we can deal with that, and how to test this deploy model. Okay, so now we have waited for this model deployment, and what we are going to do next is we will click on this model section here. If I click on the model section, it's showing me that yes, I have one new model which is available, which is actually deployed. And if this is created with the real-time endpoints, we can see that real-time endpoint in this particular section. So this is an endpoint section in the left side where we have a real-time endpoint, which is with this name, and the quota type is dedicated. It's updated on this particular time. It all looks good. I'm going inside that endpoint, and you can see right now this endpoint is available with the proper API documentation with Swagger. We have a REST endpoint URL also. If I just copy this URL and if I try to test this thing from anywhere, I'll be able to do that thing. As of now, in this particular section, we have a test tab, which is actually helping you to test this particular deployment. Now, because this test tab is asking you to choose your deployment. As of now, we have only one deployment, but when we have multiple, we can actually choose whichever we want in that. And then in the sample interface, we have to provide our input based on which is going to predict one particular numerical value with that. Let me just provide a proper input data. So I'm going to take my JSON. I'm going to just remove this and paste that JSON data. Now you can see right now this is asking for input data with the columns, and somewhere in that index and data we are providing the data with that. I'm going to click on taste. This is actually going to use my model and it's going to show me the JSON output which is based on that. Now obviously whether this prediction is meaningful for your business or not, that's something which you have to check. Now this is all for the bike rental data and it's showing me the output. Obviously if I change the values of the data, the JSON output value is going to get changed. This is showing me that my particular model is working fine. We are able to test it. We already deployed it. All the steps which we have done in this particular lab, I hope it makes sense. Now just keep one more thing in mind, that this is an automated ML. If you want more customization power on this, you have to go for designer based or notebook based machine learning, where you can actually have a full control over what exactly you want to do in that. Also, when you're going to use AI, you're not going to use machine learning directly. Your machine learning models with this kind of API deployment is already going to be done. You are going to use existing models which are going to be available with Azure AI APIs. And using that API, you're just going to use your model. You're not going to train the model in that case. I hope it all makes sense. I hope you like this particular demo video. And if you like this, please press the like button of this particular video. This really helps us in growing in this particular industry. Thank you so much. I'll see you in the next video. Bye-bye.